Aerospace engineering. Aerospace engineering is a field of engineering that focuses on the design, construction, and maintenance of vehicles that travel through air and space. It is divided into two main areas: aeronautical engineering and astronautical engineering. Aeronautical engineering deals with aircraft that fly within Earth's atmosphere, such as airplanes, helicopters, and drones. Astronautical engineering, on the other hand, focuses on spacecraft that operate outside Earth's atmosphere, like rockets, satellites, and space stations. Agricultural engineering. Agricultural engineering focuses on improving farming techniques and machinery to enhance food production. It combines elements of mechanical, civil, and chemical engineering to design agricultural equipment, irrigation systems, and methods for processing crops and livestock. Agricultural engineers work to make farming more efficient, sustainable, and environmentally friendly. Biomedical engineering. Biomedical engineering is a multidisciplinary field that applies principles and techniques from engineering, biology, and medicine to solve problems related to healthcare and improve patient care. This can include creating medical imaging systems, designing artificial organs, developing new medical instruments, or working on cutting-edge research in tissue engineering and biotechnology. Chemical engineering. Chemical engineering involves converting raw materials into useful products through chemical processes. Chemical engineers design and operate plants and machinery used for large-scale manufacturing. They work on a wide range of products, including fuels, pharmaceuticals, plastics, and food. They also focus on sustainability by developing processes that reduce waste and energy consumption. Civil engineering. Civil engineering deals with the design, construction, and maintenance of physical and natural-built environments. This encompasses a wide range of infrastructure projects, including buildings, roads, bridges, airports, dams, and water supply systems. Civil engineers work on projects from the initial planning stages to their completion, ensuring that structures are safe, sustainable, and meet the needs of communities. They consider factors like materials, environmental impact, cost, and regulations to create functional and resilient infrastructure. Computer engineering. Computer engineering is a field that combines aspects of computer science and electronic engineering to develop computer hardware and software. Some universities refer to this field as computer science and engineering. Computer engineers need to be skilled in various areas, including electronic engineering, computer science, hardware-software integration, software design, and software engineering. This discipline applies techniques and principles from both electrical engineering and computer science, and it covers areas such as artificial intelligence, robotics, computer networks, computer architecture, and operating systems. Electrical engineering. Electrical engineering involves the study and application of electricity, electronics, and electromagnetism. Electrical engineers design and develop electrical systems and equipment, from small microchips to large power station generators. Their work is critical in many fields, including telecommunications, power generation, and consumer electronics. Industrial engineering. Industrial engineering is a branch of engineering concerned with how to make or do things better. Industrial engineers design systems that enable people and society to improve quality and productivity, while at the same time cutting waste like time, materials, money, and energy. Industrial engineers make sure your mobile phone fits in your pocket while still having a lot of processing power and also not overheating. Or they can make sure it won't burst into flames while you're flying on a plane. Materials engineering. Materials engineering blends elements of physics, chemistry, and engineering to understand and manipulate materials at the atomic and molecular levels. Materials engineers study the structure and properties of materials, such as metals, ceramics, polymers, and composites, to develop materials that are stronger, lighter, or more durable. They also play a crucial role in advancing technology, such as creating more efficient batteries for electric cars, developing stronger yet lighter materials for airplanes, and inventing new materials for medical implants that can better integrate with the human body. Environmental engineering. Environmental engineering focuses on protecting the environment by reducing waste and pollution. It involves designing systems and solutions to improve air and water quality, manage waste, and mitigate the impacts of human activities on the natural world. For example, an environmental engineer might develop a water treatment facility to ensure safe drinking water, or create plans for a landfill that minimizes contamination of surrounding areas. Mechanical engineering. Mechanical engineering is one of the broadest engineering fields, focusing on designing, analyzing, and manufacturing mechanical systems. Mechanical engineers work on everything from engines and HVAC systems to robots and medical devices. They apply principles of mechanics, thermodynamics, and materials science to create efficient and reliable machines. Petroleum engineering. Petroleum engineering is a field that involves the exploration, extraction, and production of oil and natural gas from beneath the Earth's surface. Petroleum engineers play a crucial role in finding new sources of oil and gas by studying geological formations and employing advanced technologies like seismic imaging. Once a potential reservoir is identified, they design and implement techniques to extract the resources efficiently and safely. This can involve drilling wells, using pumps or other methods to bring the oil and gas to the surface, and managing the extraction process to maximize production. Petroleum engineers also work on developing new technologies to improve extraction methods and minimize environmental impact. Marine engineering. Marine engineering involves the design, construction, and maintenance of ships, boats, and other marine vessels and structures. This field encompasses everything from the engines and mechanical systems that power these vessels to the structural integrity and safety of the hulls. Marine engineers ensure that these vessels are seaworthy and efficient, working on a wide range of projects from commercial ships to submarines and offshore oil platforms. Geological engineering. Geological engineering combines principles of geology and engineering to solve problems related to the Earth's materials and processes. This field involves studying rocks, soil, groundwater, and other natural resources to design and construct safe and sustainable structures. For instance, a geological engineer might work on projects such as building tunnels, designing stable foundations for buildings, or managing natural resources like minerals and groundwater. Textile engineering. Textile engineering focuses on the design and development of textile materials and products. This field covers everything from fibers and yarns to fabrics and finished garments. Textile engineers work on improving the properties and performance of textiles, such as making them more durable, comfortable, or resistant to stains and water. They also develop new manufacturing processes and innovative textile products, like smart fabrics that can monitor health or change color. Acoustical engineering. Acoustical engineering is the study and application of sound and vibration. Acoustical engineers work on controlling noise and improving sound quality in various environments. They might design quieter machines, improve the acoustics of concert halls and recording studios, or develop noise control measures for urban areas. Their work ensures that sound levels are safe and that audio experiences are optimized for clarity and enjoyment. Optical engineering. Optical engineering involves the design and application of optical systems and devices, which use light. This field covers a wide range of technologies, from lenses and microscopes to lasers and fiber optics. Optical engineers might work on developing better cameras, creating advanced medical imaging equipment, or designing systems for transmitting data using light. Their work is crucial in fields like telecommunications, healthcare, and manufacturing, where precise control of light is essential. Nuclear engineering. Nuclear engineering, the field of engineering that deals with the science and application of nuclear and radiation processes. These processes include the release, control, and utilization of nuclear energy, and the production and use of radiation and radioactive materials for applications in research, industry, medicine, and national security. Food engineering. Food engineering is concerned with machinery and equipment that come into direct contact with foods, as well as those that provide essential services in food factories, such as refrigeration, air conditioning, steam and hot water generation, water treatment, waste treatment, and electricity generation. Knowledge of the physical properties of foods is an essential part of food engineering. Packaging systems are also key to a food engineer's role.